Hi everyone. So in this session we will see eigenvalue and eigenvectors of the last category of problems. See, the last category is symmetric matrices with repeated eigenvalues. So the matrix also is symmetric and the eigenvalues will be repeated. This kind of problems we will see here. The question, when you observe, find the eigenvalues and eigenvectors of 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. So 6 minus 2 2 is the first row. The first column is also the same. The second row is minus 2 3 minus 1. The second column is also the same. 2 minus 1 3 2 minus 1 3. Okay. So let me go with the answer of this problem. Let me take the given matrix of the in the question as A matrix. The next step, as we discussed in the previous videos, I have to find out the characteristic equation. S1 is nothing but sum of diagonal elements. So it is 12. And S2 is nothing but sum of minors of diagonal elements. So it is S2 is 36. And S3 is determinant of A. When I expand the determinant, 6 times 3 minus 1 minus 1 3 minus of minus 2 times minus 2 minus 1 2 3 plus 2 times minus 2 3 2 minus 1. So I get, after solving, I get S3 value as 32. Now the characteristic equation of a 3 by 3 matrix is lambda cube minus S1 lambda squared plus S2 lambda minus S3 equal to 0. So when I substitute all S1, S2, S3 value, I get the characteristic equation as lambda cube minus 12 lambda squared plus 36 lambda minus 32 equal to 0. Now next job, I have to find out the eigenvalues by this log L division I'm solving. Because it is of degree 3, I will take the coefficients 1 minus 12 36 minus 32. So by trial and error method, I am putting lambda equal to 2. I have to add here. So 1 plus 0 is 1. Here I have to multiply 2. So it is minus 10. You multiply, so you get minus 20. This is 16. 2 into 16, I get 32. The remainder is 0. When the remainder becomes 0, it is understood that the value which I have chosen is right. So the first eigenvalue is 2. Next, by using this coefficients, I have to form a quadratic equation, lambda squared minus 10 lambda plus 16 equal to 0. When I solve this, I get 2, 8. So what are the eigenvalues? The eigenvalues are 8, 2, 2. By this time, you have to observe that the eigenvalues are repeated. So the matrix is also symmetric matrix. Now my next job is I have to find out the eigenvector. First you choose the repeated value lambda equal to 8. When I choose the non-repeated value 8 with the same eigenvector equation A minus lambda into x equal to 0, put lambda is equal to 8. So the matrix becomes minus 2, minus 2, 2, minus 2, minus 5, minus 1, 2, minus 1, minus 5 times x1, x2, x3 equal to 0. Now select the last two rows as we discussed earlier. X1 by it is minus 5, minus 1, minus 1, minus 5. X2 by it is x2 by it is minus 1 minus 5 minus 2 2, and x3 divided by it is minus 5 minus 1. So just by cross multiplication of these values, I get x1 by 24, x2 by minus 12, and x3 by 12, which I can divide by a common number 12. So I get the first eigenvector x1 as 2 minus 1 1 for the eigenvalue lambda equal to 8. Next, lambda equal to 2. I will take lambda equal to 2. When I take lambda equal to 2, the matrix becomes A minus lambda I into x equal to 0. Put lambda equal to 2. So I get 4 minus 2, 2, minus 2, 1 minus 1, 2 minus 1, 1 times x1, x2, x3 equal to 0. When I just simplify this, I get, see, when you observe this, all these three rows are same values. See, by doing small calculations over there, you can see that it is 2 minus 1 1 2 minus 1 1 2 minus 1 times x1 x2 x3. So all these three are the same equation. See, 2x1 minus x2 plus x3 equal to 0. Now in this equation, you put x1 equal to 0. When you put x1 equal to 0, it becomes minus x2 plus x3 equal to 0. When you solve, it is minus x2 minus x3. So when I cancel it, you get x2 equal to x3. So this is nothing but x2 by 1, x3 by 1. So this is x1 value and this is x2, this is x3. So x1 value we have made it as 0. So the second eigenvector x2 is 0, 1, 1, corresponding to the eigenvalue lambda equal to 2. Next, this is what I told you, that this is something which is different. To find the third eigenvector, I have to choose the third eigenvector x3. Sorry, here it is x3 as LMN which is orthogonal to x1 and x2. I have to choose the vector x3 as LMN, which is orthogonal to x1 and x2. So orthogonal means x1 transpose x3 equal to 0. So x1 transpose, what is my x1 matrix? My x1 eigenvector which I got is 2 minus 1 1. So I hope you remember in the previous slides 2 minus 1 1. So when I take transpose, so as I explained you earlier, transpose is nothing but we will just rearrange the rows and columns. So here it is column, so it will become a row. 2 minus 1 1 times multiplied by x3. So x3 is LMN. So when I multiply, I get 2L minus M plus N equal to 0. Next, this is 0L M plus N equal to 0. When I solve these two equations by the same method, I get L by minus 1 1 1 1, which is equal to minus M by, and the same thing. So I get the x3 vector as 1 1 minus 1. So this is how we find out eigenvalue and eigenvector of a symmetric matrix with repeated eigenvalues. Thank you.